Learners, in the first part of the program, we have learnt about the historical development of telephone exchanges and their electromechanical implementation. Now, in this program, we will learn about electronic telephone exchanges.
Welcome friends. Now the technology advances in the switching has taken place. Basically, emergence of computers brought a paradigm shift in the switching technology. The physical path that was blocked for the entire period of conversation is not required anymore. Now we use what are called the multiplexing techniques, where the sampling is done and only sample data is sent out. The time division switching is based on the time division multiplexing, and that is the one that actually is the one very commonly used in present telephony. Now time division switching is essentially based on the principle that a voice signal is a baseband signal. In telephony, as you know, the baseband signal is just 0 to 4 kilohertz. The band is very small. So the baseband signal, if it is 4 kilohertz, then our sampling theorem tells us that we should sample the signal at least double the frequency of the incoming signal. Then we can have a sufficiently error-free communication link, and it is quite reliable link. So sampling theorem is the one that determines that for telephony signal, you should sample your telephone signal at least at 8 kilohertz frequency. Now 8 kilohertz frequency means if you have a particular channel, then I can sample that channel at intervals of 125 microseconds. Okay, 8 kilohertz will equivalently 125 microseconds. So after every 125 microseconds, if I come and take a sample from a voice signal on a telephone line, and if I send it out, then at the receiver end, the signal that is regenerated will be reliably good, audibly clear, and without any hindrance. So now if you see, if I have to visit these samples I have to visit this particular channel at 125 microseconds, it is a quite large time. In between these 125, I can do slots of time and do sampling at different signals or different channels and put them together in a fashion of time division multiplexing. Okay, so this is the basic principle that is governing the time division switching. Now, when I do a sampling, I don't keep on the pulse that I'm sampling on for entire period of 125 microseconds. Even 5 microseconds sample is good enough for me to pick up a sample from a given analog signal. Now, when I use just a 5 microsecond pulse per channel, and if I have 125 microseconds in between my two successive channels, then I can possibly squeeze in 25 channels before I have to come back to my first channel, right? So this is a quite efficient way of sending the signal on the given particular data link. Now the analog signal that we sample needs to be converted into digital signal, which is typically a 8-bit coded signal, and then we can handle it using the time division switching. This time division switching I am showing here. What is done is that, say, I have different channels. Now, like in our earlier example, we said that we can have 25 channels. So, if I say n is equal to 25, then what I do is that these are my source, 25 sources, and the signal that is being picked up from this, since it is a digitally coded signal, I can store it in the memory of a computer in form of bits and bytes. I have here a memory bank, which is again exactly equal number of slots are there, memory slots, which are equal to the number of channels that I can handle here. Okay, so per channel here I have assigned one memory slot. Now what is done here is that when I do the polling at the input, I have, say, number 2 caller wants to speak to number 21 caller. Okay, then the data, when it is polled, it is given and stored in the slot corresponding to subscriber number 2, the channel number 2. But I am not going to give it out to immediately. I keep on holding this memory, and since I know that I want to send this to the 21st channel user, I release the data from this memory only when the polling of 21st channel is happening. Okay. So effectively I have shifted my data from channel number 2 to channel number 21 using this memory switch. Now naturally for this particular operation to take place, I need a lot of control. I have to keep track of which channel is being assigned to my caller. Like here, channel number 2 is assigned to the caller. When the caller had made the call and tipped in the number or dialed the number, that number we have already assigned and some output channel here. So that number channel is also to be remembered by this control unit. Okay, and this control unit is the one who is going to take care that okay, whenever the polling or the sample of number channel 2 comes, and when it is being polled from here to the output channel, when 21 comes, then we are going to release this data and be prepared for the next sample from the channel number 2 in its next cycle of polling. So this whole operation is going to need a lot of electronics and computerized software support, which is only possible due to our advances in the electronics that have taken place. But now here if you have seen, what we have done is that we have not established any physical channel in this particular scheme. There is no dedicated channel between the caller and the subscriber to be called. Basically what we have done is that the data from the caller is being stored at a particular place and it is released at certain different time period to the party who is being receiving that signal. Okay, so essentially there is no physical channel which is blocked for the entire duration of the conversation. Here we had released that physical channel the moment that data from channel number 2 is stored in memory location 2, and then it is again captured when channel number 21 is given that data from channel number 2. That's all is the physical link that is taken place. But in between we have been able to cater to other 25 channels while this one particular conversation is happening. So this is the most efficient way rather than physically blocking the 2 subscriber ends for the entire period of conversation. So advantage of this time switching is that the multiple users can be handled using the same physical space, and so we can reduce the physical space as well as the hardware that is involved, because now we don't need that many number of wires physically present, but it is number of just memory locations which are sending data from one point to other. The only physical link is between the exchange to the interface unit at the user end as well as at the outer end, as we will see in the electronic exchange that I am showing you here. Here you have what is called connection unit. Now this connection unit is the only one which is having the subscriber phone lines physically coming in and being connected to the interface. Now this interface, after the interface, all the subscriber lines are handled by just one connection between the switching network. And the same is for the other receiving party also, that a single line is given out and that interface gives out the data to different subscribers' phone lines. So the physical contact of the wires or the physical medium that is needed for a particular telephone line is now reduced drastically, and entire other communication is now through a single channel. And as you can imagine, this need not be a physical wire. Now in the days of our advanced communication, you can always have wireless links here, you can have satellite links here, anything is possible, and those channels can be optical fibers also, it can be either transmission lines also, anything is possible. Now in this case, this control unit is a main workhorse of the exchange, along with a maintenance unit and some memory naturally you will need, and a stored program, because essentially this whole operation of this computer controlled exchange or electronic exchange is going to be based on certain program that is already stored in its memory and operations are happening. So in connection unit, if you say that it provides the battery supply to the subscriber lines, that is the first function of a connection unit. Then converting the analog speech signal into the data received from the caller into a digital form, that is also done by the connection unit. Then feeding various tones to the subscriber like a dial tone, busy tone, ringing tone, all those tones are also provided by this connection unit only. Also they can provide you play recorded announcement also. Sometimes you get that this number cannot be reached, or caller is right now busy, please dial after certain time. These all the recorded messages can also be fed through this connection unit only. Now the switching network, which is the main workhorse, it establishes the connection between the calling and the caller subscriber. This is the basic work that is happening is actually through this switching network. This facilitates the transmission of the speech signal between the 2 points, as you know, and it is controlled by the control unit. Now this control unit is very important. It is a centralized unit, and that it monitors the controls of all the activities of the exchange, not just the switching but all others also. It is basically a computer or microcontroller, if you want to say, and it operates on the principle of a storage program. It's like your computer program. You have certain kind of program, that set of instructions which allows a particular unit to function in a designated way. So that store program is there in the SPC, and all the switching procedures to set up the call are already stored in this program modules. Now this control unit performs various functions like setting up of the call, means as we said that when a caller makes up the call, that is that call has to be set up. Also the making and breaking of the call, supervision of entire operation while that calls are being operational, then charging, depending on what kind of call has been done, you have to do different kind of charging. So whether it is a STD call or it is a local call and so on and so forth, all those are done by the control unit. There is a maintenance unit also known as the operation and maintenance center also, and it monitors basically the working of all the units. It watches the subscribers' meters, stored meters, information in generating bills, as well as it manages the traffic data. If there is too much of traffic load, then it can provide certain kind of support systems for handling that kind of data. And of course, the advantages of electronic exchange as it allows handling of analog as well as digital signals, and which improve the speed and quality of the data transmission and allows facilities like internet connectivity also nowadays. It requires less maintenance because there are no moving mechanical parts here. Its entire installation and maintenance of these exchanges in the cost and time effective, as well as you can increase the capacity of this exchange also quite easily, because it is basically the electronic circuit board that you have to add. You don't have to add physically any electromechanical switches in this particular case, that if you want to augment the capacity of that exchange. And so it is quite easily augmentable as well as expandable. So in all, we have seen today various telephone exchanges, their type, how they evolve, and how the electronic exchange is operational, and how it comes handy and efficiently it handles our calls. I thank you for your attention.